Hi there. For our first video lesson, I thought what we could have a wee look at is what's known as completing the square for a quadratic. We have met the quadratic before. You will recognise the quadratic from its general form. It takes the form ax squared plus bx plus c, where a does not equal 0. Now that's a very important point because for an expression to be a quadratic, you must always have an x squared term basically, and it will be the highest power in the expression. So you will always have an x squared somewhere. You might not have an x term and you might not have a number term, but you will always have the x squared term, and it will be the highest power within the expression. Now, what we can do with a quadratic is a variety of things. One of the things that you have already done and you've had practice in, you'll have to put up with me moving the screen about because I'm just getting used to actually this format of putting the video together. But if you can put up with that, that would be great. So the first thing that you learned to do was to factorise. If you remember, we looked at factorisation. So that was the first thing that you've had a go at. Now, if you remember, you could get all sorts of factorisation. There were basically three types of factorisation that you met. Single bracket, difference of two squares, and the trinomial. Now, you can go back and look at your notes if you so desire, but it's not actually required for what we're about to do because this is a new format. But format 1, if you like, that you have used is factorisation. Okay, so the first format, so for instance, it would be useful for me to remind you of this type of factorisation. If you have an expression where you have x squared minus a number term, usually that number term will be a square term, and that's the only way you could actually factorise this. So we use the fact that that actually can be written as a square term because we can rewrite that or put it in the format x squared minus 4 squared, i.e. the difference of two squares being x squared minus 4 squared. If you can carried on factorising that, what you could do is use the double bracket, whereby you would get x to get our x squared term. You would use the 4 using the fact that that's a square, and use that in your factorisation. Now what we always have to do is to get the signs correct. The fact that that's a negative tells us we have one positive and one negative. We have to have different signs to achieve a negative for a number. Now what that therefore facilitates is the fact that you've got a 4x, which is a plus 4x, and you have a minus 4x if you use FOIL, your inner and your outer. So that would give me a plus 4x, a minus 4x, which means that those two would add to give you 0. You can write it in if you want, just in case you've forgotten that, adds up to 0. So there is no x term, okay? But you still have your x squared and you still have your minus 16. So that is something that we have already looked at. If you can't remember that, then you should go back and revise it, okay? So factorisation, the difference of two squares, that's how we do it. Now, a slightly variation on this is a second format that we're going to look at, which is the completing of the square. Now, what I can do is I can take a quadratic expression and rewrite it or rearrange it in such a way that I can get x plus a all squared minus c squared. So if you look at what we have here and what we have here, we might think, well, how do we achieve that? How do we go from the full quadratic to this? So this is the completing of the square format. Okay, that's what that is. It's a completing or the completed square format. Okay, so how do we do that? Well, what I'm going to do is I'm going to show you examples of how to do that. Okay, and I'm going to start off with a particular, well, we're going to start off with easier types. Okay, so easier types, what do I mean by that? So if I give you an example, okay, if I say x squared, okay, plus 2ax, okay. Now what I can actually do with that is using the difference of the square. You'll see this when I write this, hopefully, that if I change that to that, you can see I have a square term minus a square term, okay? So, and the thing is, what I've used is this part here where I've actually halved that term to give me a and a, okay? Keep that in mind, okay? And what we will do is we will have a look at how that is useful to us. One of the things that I often explains to students is that this and this are actually the same thing. It's just taking that quadratic and changing it into that format. Because if I take this here, if I was to expand that, you know that that means x plus a times x plus a, yeah, minus a squared. So what that gives us, it gives us x squared. If I use FOIL, that's x squared. To get my last term, if I do plus a times plus a, that would give me a squared. Yeah. If I multiply that, that's the inner one, I get plus ax. If I do the outer one, I also get plus ax. Yeah. And that was a plus a, because that was plus a times plus a. Okay. Now, that's just expanding that. If I put in minus a squared, okay, you'll see why we need to put this in a minute, because if I tidy up using like terms, that gives me plus 2ax plus a squared minus a squared. If you gather like terms in terms of these two here, you're left with x squared plus 2ax. Okay, now I could have actually done that all in the one go, but I decided just to leave it separate. So what you can see is by taking that x squared plus 2a and changing it into this, I actually have got the exact same thing once you expand the brackets. So it's a connection between these two things that we're actually going to do to complete the square. So how do we do that? Okay. So if I give you an example of that type, example 1, an example of that type could be x squared plus 10x. Okay. Now, if I have a look at that term there and change that, okay, or use that, what we actually have to do is we take the 10, okay, and we divide it by 2 and it gives us 5, okay. So I can rewrite that as x plus 5 all squared minus 5 squared. Okay, and if you have a wee look at that, that gives you x plus 5 squared, and if I simplify that, that gives us 25. Now, what we've actually done is we've converted that into the completing of the square, okay? Because what we've done is we've taken the term And we've found out what A is by dividing the 10 by 2. So A is what you use in your completing the square. So you half the 10 to give you 5. And then, so you get x plus 5 all squared minus 5 squared. Okay, let's have we'll go at another one, and you'll see how it works. If I have x squared minus 16x, okay, so we're going to take minus 16, take the sign with it, divide it by 2, which will give you minus 8. Okay, so if I take that there and I complete the square, what I would do is x minus 8 all squared minus 8. Now, you could actually say minus 8 all squared there, if you like, but it works out to the same thing because you're left with 8x minus 8 all squared minus 64. Because negative 8 times negative 8 is 64. So that would be the completing of the square. Now, if you multiply this out, you would actually see that I do get back to x squared. I'm just going to do that in pencil just to show the difference, okay? That it is actually the same expression. So if I take this here, x plus 5, x plus 5 minus 25, okay? So these two multiplied, the result of that would be x squared to get this one. This one will give me plus 25. This one gives us plus 5x. This one here also gives us plus 5x. And then we've got minus 25. If I take like terms, I've got these two, which gives us x squared plus 10x. And if I take the plus 25, I'll wiggle that one, plus 25 minus 25, it disappears and you're back to your original. Now I could do the same for this one too. I would have, just move this in, x minus 8 times x minus 8 minus 64, which would give me x squared, don't need that bracket actually, to give me that one. Minus 8 times minus 8 is plus 64. Minus 8 times x is minus 8x. X times minus 8 is minus x. And you've got minus 64 there. So again, gathering like terms, you do get x squared. Let's get rid of that, it's kind of obscuring. Minus 16x plus 64 minus 64. Terms of numbers, these disappear, and I have got back to my original expression. So this idea of taking what the number is in front of x and halving it and do a completing of the square is actually achieving the same expression as a completed square expression. So now we know that, we can use that to complete the square. I'm just going to stop the video because I'm going to do examples on a separate one. Okay.